So before we start this particular video, I wanted to actually talk about a very small thing. So this video is going to actually help you understand a real system design interview scenario. We are going to try to mimic a 45 to 60 minute kind of like a round where we are going to solve a problem very similar to how you will solve a similar system design problem in this short time frame. Now, of course, when you work as a software engineer in a company, you have relatively larger amount of time and you can do a lot of more deep dives in even very small level features. But in an interview, the temperament is different, the approach is different, and a similar scenario is actually explained in this particular video. So do consume the content based on that. Also, if you want to see more deep dives and want to understand these topics in a much more deeper level concepts, then do check out the link in the description section below for our system design 2.0 cohort, where we have talked about a lot more concepts in a lot more detail, which will make you definitely a better software engineer. So let's just start the video.
Sanket, so today we will be taking your system design interview, and this is going to be a high level design interview which we'll be taking today. And the process would be that we will be spending about 45 minutes on this whole interview round. And about 40 minutes actually discussing the problem. And in the end, if there are any questions or anything follow up questions that you may have, we can use the next 5 minutes for that. The flow would be very simple. I would be calling out a simple problem which I would like you to design, right? And you have to go ahead with the process of designing the functional and the non functional requirements for it. And then moving forward, there will be a discussion about making the whole system all together. And while you're designing it, I will be having a couple of follow up questions in between. So I will be stopping you here and there in the process and asking clarifying questions wherever I feel like I need some answers. And then you can go ahead and start with the design and like continue on it. Does that make sense?
Yeah, that makes sense. Sure.
Perfect. Okay, then let's get started without wasting any time. Today, what we're going to do is we're going to design a platform, which is a coding platform known as similar to Leetcode, right? If you already are aware of how Leetcode already works, if not, let me give you a brief overview. So it's basically a platform where you can practice coding questions, and along with that, you can also be a part of competitions on Leetcode. So there are competitions happening where a couple of people participate in it, and there's like a leaderboard that comes after it. And along with that, if you just want to practice some coding problems, you see the question, and along the side you also see a place where you can write the code, where you can submit the code, and then your code basically gets assessed. These are basically what any primary coding platform have, right? And this is going to be your problem statement for today. Yeah, so now you can go ahead and start implementing it.
Okay, sure. So what I can understand is we have to design something similar to Leetcode, or let's say Code Forces. Okay. Um, so it's a code submission platform. So let's get some consensus on the functional requirements that we would like to support. So I believe one of the main core functional requirements should be that the users should be able to list the set of problems, and users should be able to submit the code solution in some preferred language, right? So we need to probably support a set of languages altogether,
Yes.
right? And users should be able to see their evaluated submission, that whether it went fine, whether it was a time limit exceeded, whether it was like success, error, whatever it was. So that should be one case. And this should be like old submissions should also be visible. Like people should be able to see what all old submissions should be there. What I can understand from platforms like LeetCode and Codeforces, just correct me if I'm wrong, for each problem, we need to technically support multiple test cases because there might be different type of corner cases that we might have to support. Is that a correct assumption to go for?
Yes.
So the system should be having,
Just that one thing, we don't need old submissions. Like the main criteria of the platform will not be able to see the old submission. So it's a good to have,
okay,
but it's not going to be our functional
okay.
requirement for this
Old
case.
submissions is kind of like a good to have. Okay, let's go with that. and we should be able to support multiple test cases. In the interest of time, I believe maybe we can talk about the leaderboard aspect, but let's see how much time we have left. I'll also mark this as good to have because I can see we already have a lot of things to discuss. So let's see if we can have some ideas or some brief ideas on leaderboard. Then we can talk about it. Otherwise, I'll try to make sure that we are able to support these many set of functional requirements. Anything else that you would like me to add here?
These looks good to me.
Okay. Now let's talk about the non-functional requirements. Okay. So, what are going to be the set of non-functional requirements? So, I believe what I can understand from a code submission platform like Leetcode is that maybe there can be sometimes, maybe because of a lot of rush on the platform, maybe during some competitions like ICPC, there might be a case that users' submission is evaluated after some delay, maybe let's say 10-second delay or one minute delay, but their submission is accepted always. Like if I make a submission request, then that submission is accepted always. It might be evaluated in let's say 10 seconds or 30 seconds. So what I can see is that the availability of the system should be high, right? We would like to make sure that users are able to at least submit the problem and get them evaluated, let's say after some time. That is going to be important. That what does that mean? That maybe let's say, uh, like for example, the submission is evaluated, but the users might see the response in a bit delayed fashion. Even let's say with respect to leaderboard, there might be a case that some user has jumped 10 pointers up on the leaderboard, but the leaderboard might be reflecting the changes after some time, and that is something which is very common in most of the coding competition, that even after the competition ends, sometimes after let's say plaque checks and some extra value some extra processing, the leaderboard sometimes do get updated here and there. So that means that we are not going to prioritize a lot on the consistency aspect of the submissions. Instead, availability is going to be something that is going to be super important. A very important aspect here I can see about Leetcode is that because we are going to take some coding solutions from the users, which we have to probably run on our servers. That means security and fault tolerance is an important aspect to our platform, because we need to ensure that we should not be running any malicious code. We should not be entertaining any irrelevant code altogether. Right. So that is going to be one more important non-functional requirement. I believe we should be able to support good scale of application, because during competitions like ICPC, even Leetcode weekly contests, we can see good influx of users who are going to technically, I would say, approach the corresponding platform. So talking about scalability, so I'm going to take some arbitrary numbers and then we can see if that technically works for us. So I'm going to expect that, let's say, on a platform like Leetcode, we have 1 million, let's say, monthly active users, and we can take probably 10% of it, or let's say 50% of it, that is 5 million, let's say, daily active users are there. And assuming that, let's say, every users make, let's say they are practicing a lot, every users make at least two submissions per day. So that leads to the total submissions per day count again back to 1 million, right? So if we see that, okay, what is the QPS we have to probably support in terms of taking the submissions, that is going to be, let's say, 1 million submissions a day, and that we can divide by 86,400. I'll take a round of figure as 10 days per 5.
Can you
So
scroll
that,
down a bit?
yeah, sure. So so what I was talking about is we can take 1 million submissions
Got
per
it.
day, assuming two submissions per user. And then 10 days per 5 has approximated the total number of seconds in a day. So the QPS will come out probably as 10 queries per second. This is going to be for average submission. We can assume the peak load, let's say, to be 25x of it. So even if I assume the 25x peak load, that will be 250 QPS that we might have to support. So that should be a reasonable amount of, I would say, scale that we might have to eventually get to. And this is specifically targeting the submissions that we are considering, right? We can do the storage estimations as well, but I would like to pause on that because we still don't have clarity on how we are going to store the solutions. So we can maybe come up to that later if we need it.
I think that
Any
is fine. Storage is fine. Just one thing over here that do you think latency would be something we need to be talking about? because a person is submitting their solution. Would you How would you want to scale the latency of the system over here? Because if
Yeah,
ideally in a
I'll.
platform you
Mhm.
get your submission results quite quickly.
So as I already mentioned that in most of the coding platforms, what we can see is that, for example, even if we take the example of Leetcode, there are two type of users. One is a premium user, one is a non-premium user. So like for example, for non-premium users, even if they submit the solution, it takes some time for them for the system to start picking their solution to be evaluated. And that's what our requirement is also there, that we would like our solution to be accepted by the system, but the system might revert back to us about the evaluation of the submission after some time. But how we are going to give a good user experience to the user so that the user is not blocked for, let's say, 1 minute on the loader, that is something that we can talk about in a minute once we start doing the design.
But
But I
even then,
believe
I would say that we would like the system to maintain a low latency. Ideally, even for non-premium users, you do get a response in 10 seconds, 5 seconds. It doesn't
yeah,
go up
10
to
second,
like a
yeah,
minute.
we can define an SLA. We can define a
Yeah.
maximum SLA that we can have. So what we can have is, let's say during non-competition hours, we can assume that, let's say the maximum delay that we are going to give the user for any submission, and let's say the P99 for that can be 10 seconds. But during peak hours, for peak hours, that means, let's say during competitions where we can have a huge influx of users, we can assume that to be, let's say, around 1 minute. This is in very
I
much
don't think
contrast to
even
the
in
existing platforms.
I don't think even in competitions it should take 1 minute for the evaluation because it's a time-based competition. So ideally, we would
Uh,
not like a student to waste a whole minute in it. In general, I mean, just for the sake of simplicity, let's just maintain that we would like the system to be having a very low latency, and in all scenarios, we would like the response to come on within 10 seconds itself. That
That
would be a
that
simple.
that can be a contradicting opinion on a particular set of aspects. Why? Because a few because that will also lead up to the fact that every question on the platform needs to be making sure that there is a certain set of time period within which that should be valid. For example, a question that is evaluated in 1 second for C++ will take at least 5 seconds for Python. The moment a question has been put that takes at least 2 seconds, which is very general questions, let's say on platforms like Codeforces, those questions can take up to 10 seconds for Python. And this is just for a good case where, let's say, we don't see any spike in the load or something. So
Yeah,
these
that is
SLAs
okay.
are going
I
to.
understand that. That's why I'm saying in general, let's maintain like a 10-15 seconds SLA for the sake of simplicity of
But
our
what about for slow
design.
languages like Bash and Python?
Yeah,
What do we
we can
think would be
assume
a
that
good SLA for that?
I for now we can simplify our system in a way that we support popular major languages like C++, Java, and Python itself for the system because we have to design a basic system first and then we like to scale it. And the SLA could be 10-15 seconds max, and that's how I think we should
Okay,
proceed and
so let's say for
design our
peak hours, let's try to make sure that we do the SLA within 20 seconds, 20 to 30 seconds for a good buffer we can take, and SLA of 10 seconds for general traffic. That is something that we can start picking up and keep in mind that these SLAs are overall met. Okay, this is going to always ensuring the fact that the problem statements are written in a way that their test cases for the fastest language that we consider, let's say C++, is getting evaluated within 1 second or max 2 seconds. If the problem statement for them is higher, the SLAs are going to get higher. This is something that we can get a consensus on, I believe.
Okay.
Cool. So with that in mind, what we can do is we can at least get a basic design ready, and then maybe we can see what all things we have to work on that. So assuming that we are going to have a set of clients, this is mostly going to be web clients that we are going to support in most of the systems like LeetCode. That's the primary one. What we can have is we can actually divide the responsibilities of the system within a couple of services so that we can ensure that during peak load we can scale up things accordingly. So what we can have is this client is going to send a request that is going to be technically collected by our API gateway. This API gateway is going to technically ensure that we have all the right authentication, authorization, rate limiting, all of these in place. So for any incoming request, we are going to have, let's say, an API gateway altogether. Now, how these requests can actually look like. So, for example, we can have a like we don't like for the sake of time we don't want to talk about, let's say, I believe the admin part. So I'll just keep in mind the submissions part. That let's say how the submissions API is going to look like, assuming a REST convention altogether. So we can have slash API slash v1 slash submission, and let's say assuming with a post request, we can have a create submission API. Right. This is going to take a payload. And inside the payload, we need a couple of important things. First is going to be the language in which the submission is there, which is going to be, let's say, some kind of like a string, enum defined. We can have, I would say, payload, or I would say the code, which is going to be the code that the user has to technically, that the user wants to technically submit. As of now, I'm assuming that all the input driver code and all of the output code also the user is going to put. If you need stubs, we can talk about that later. But for the sake of simplicity, for now, let's keep this. Along with that, there is going to be, let's say, a problem ID for which we would like to do the submission, right? That on which problem we are doing the submission. And that's it. For now, we can start with that, right? And there is going to be similar kind of one more API. This time, let's say a get request to slash submissions. This should be submissions slash colon ID that is going to give us a get a particular submission, get a submission. And similarly, we can have slash submissions with a get request to actually get all submissions. Right, these will be the initial set of APIs. If we want to add something, we can add to these APIs later, but I guess we can start with these set of APIs. So what we can have is we can have an API gateway that will collect all the rate limiting and authentication. And what this is going to do is this is going to, let's say, forward the request to a dedicated service, which is going to be our submission service. Okay. And this submission service is going to technically be a stateless and horizontally scaled service altogether, right? Right. So this is going to be a horizontally scaled submission service, right? So this submission service will be having its own load balancer so that we can handle all of the incoming scale altogether. Now, the responsibility of the submission service is not to actually do the actual submission. Why? Because there can be a lot of submission requests that we can get. For example, in peak load, we can get 250 submission requests per second, and every submission can take some time to be evaluated. Because for every submission, what we have to do is we have to run the code, pass it to the test cases. Let's say there are 100 test cases. So for 100 test cases, we have to run that code, and then all the 100 test cases has to be matched to the original corresponding output test case. So all of that load we do not want to put on these set of machines, because the set of fleet is going to help us collect the set of requests. Okay. So what they are actually going to do is they are actually going to process all of this asynchronously. So what we can have is we can have a message queue here, right? We can have a message queue, let's say something like a Redis queue altogether, that can actually take a payload from our submission service. The submission service is going to technically just collect the request from the user and add it to the message queue. The moment the payload has been added to the message queue, we are going to immediately send the response back to the user that your submission has been collected and it is being evaluated. In this way, we are going to technically ensure that the user doesn't have to unnecessarily wait for all the test cases to run. Right? Let's say if there are 100 test cases, otherwise they have to wait a lot of time. This is going to ensure that at least the first response to the user comes in like within a few milliseconds, because this is just a very fast round trip and there is no necessary DB call altogether as well. We just have
And
to
where are you
submit this
going to
payload in the
store
message
the
queue.
submission meanwhile while it's getting evaluated?
Yeah, so I'm coming to that. So now there is one thing that can come up, that okay, let's say what if this message queue turns down, or let's say there is a failure in this message queue. The moment we see the problem that okay, there can be a failure in this message queue, we can try to get a more I would say better platform that can help us to make sure that once the message has been added is never lost. Something like a message, something like Kafka, right? Because the moment we add a message to Kafka, we can be rest assured that that entry is always going to be there and we are not going to lose the entry, and we are going to send the response back to the user only when the submission has been added to the corresponding Kafka topic altogether. So that is going to be something that we can technically take. There is one small issue that I can think about with this particular approach is that let's say if this submission payload has been added to Kafka and has not been persisted to DB, the users will not be having any, let's say, unique submission ID with them that they can later check for, because yes, submission is still being evaluated, but they need, let's say, a submission ID that they can later reconcile with. That is the point where I believe like just putting into Kafka might not be a good solution altogether. And what we can actually do is we can stick to our message queue idea, and in this particular round trip we can have a submission DB. We can have a submission DB. Inside the submission DB, the moment we collect the submission, then from there we can put that submission in the message queue. And what we can also ensure is that we make an entry in the submission DB as well. Because the moment we make an entry in the submission DB, we will get a unique submission ID that we can later use to reconcile. And that
So it will only
submission,
have unevaluated submissions. Sorry to cut you off. So it will only have unevaluated submissions or both evaluated and unevaluated
I
submissions.
believe we can keep both. For each submission, we can keep a status enum that, let's say, it is pending, it is evaluated, it is TLE, MLE, correct, whatever, wrong answer, whatever it is. All that's kind of like a status we can keep. So now what we can do is we can first add the data to the submission DB. Once we have a basic idea from the submission DB that, okay, this is the new submission created in a pending state, then with that submission ID, we are going to, so this is going to be, let's say, part one, and then this is going to be part two, and this is going to be, let's say, part three. That now we have the submission ID. With that submission ID, we should add a payload in the message queue, because later what I plan here is we are going to have a fleet of evaluator service as well. This is going to be a separate fleet of evaluator service, right? Evaluator service. Now, what this evaluator service is going to do, it's kind of like going to consume from our message queue one by one, right? It's going to consume from our message queue one by one. And which submission it is consuming, it might have to later update that in the submission DB as well about the status and all. So for that, we need the submission ID. Hence, we are going to first add it to the submission DB and then only put it in the message queue. This is not going to add a lot of things to the latency, because this is going to be a simple insert call that we are putting in the database, right? If we want to improve on it, we can talk about that later. Let's say how we can improve this insertion so that we can even minimize the latency.
Can
Now,
you talk a little bit about what kind of DB the submission DB would be? Like what would be the schema and how
definitely.
exactly are you planning to store it?
Definitely. So, in the submission DB part, I believe we do not have to do a lot of joins, right? I don't see a lot of relational aspect. The only thing that I see is that a user will be having a lot of submission, and a submission belongs to a user. So, that's the only thing. And I believe this kind of a simple relation we can also manage in a NoSQL. So, I believe any kind of a database, be it SQL or NoSQL, might be okay. For simplicity, we can start with a MySQL instance altogether, right? And with that, we can have a simple schema where we are going to have a submission, a unique ID for the submission, a problem ID for which the submission has been made, the user ID who has made the submission, status of the submission, a code that the user has made. This code doesn't necessarily need to be the same string that the user has actually submitted. What we can do is we can save this code in a blob storage separately, and then put that blob storage link also here. Or if we know that the code is going to be within the bounds, it's not going to be too long, because generally lead code solutions are not that too long, we can directly put that as a string as well. It should not harm the system much. Let me see if we need anything else in the submission DB. Um, I believe for each submission, we can also maintain a score, that what was the score of the submission later, that let's say there were 10 test cases, how many of them actually passed. So that kind of a
You mean
thing
submission
we can,
result? When you say score, does that mean submission result, like what the result of the submission was?
no. So when I say score, I mean that when this submission has been evaluated, what is the score of the submission? Like sometimes in competition, every problem has, let's say, a score of 20, sometimes they have a score of 30. So in that score,
Got
what
it.
was the score of this particular submission? This is more relevant for competition kind of like a scenario. So just to keep it kind of like
And where will you
exchangeable.
store the result of the submission? Like
Yeah.
after it was
So
evaluated, where
yeah.
the that will go?
Yeah. So once if though that will be technically more, I would say, handled by evaluator, because now how the submission is going to technically work is that for every submission, whenever a code has been added, now that code has to run on multiple test cases. So technically, we need a table which is going to be submission test case, kind of like a join table, inside which we are going to have a submission ID, right? We are going to have, let's say, a test case ID, right? And then how this submission performed in this test case, we can put a result, that what was the result for this particular test case, right? So this kind of a separate join table we can actually keep. This is going to help us to track that if there are multiple test cases, then each test case is separately evaluated, and its status can be separately tracked, and then later, based on when all of the test cases are done, we can update the corresponding score. Does that make sense? Like in the
So
submission DB, we can have
submission
a
ID is like a foreign key for the submission table is what I
table.
can
Yeah,
see.
this is
So
yeah,
let's
this is
say
the
for
submission table.
one submission, there were 50 test cases. Does that mean
Mhm.
you'll make 50 entries in the submission test case table for that
Yes, because
particular
it's a joint
submission?
table. It's kind of like a joint table, although test case is not a separate table that we are keeping as of now. We'll talk about test case in a minute, but it's going to keep 50 entries altogether.
Is that very scalable? Like a person is maybe making so many submissions in one day, especially in a competition, they make too many submissions. And with that, we are scaling it with 50 submissions more later. Do we need to really store that information? Can we not directly just evaluate and have a one single submission result? Do we really use that information of how that submission performed for each and every test case? In the end, I think I'm just more concerned about eventually how many test cases passed.
Like this can be something that we can figure out for our functional requirement. Like for example, there are some platforms. You can tell me what do we would like to support, but maybe there are some platforms, let's say something like a Leetcode and HackerRank, that can tell us that okay, exactly for which test case, what was our answer, and which test case failed. And there are platforms like Codeforces that just tells us the only failed test case and how many test case actually failed, and it just tells us about the first failed test case. So what do you think, what should we support? Do we and or one thing can be something like, let's say, CodeChef. They don't even talk about any failed test case, at least earlier they didn't used to. So what do you think we should support? We can tweak things according to that.
I think ideally in this system, I would be okay with the fact that a user made a submission and in the end, they just get to see how many test cases passed and how many test cases failed. There are platforms which show you exactly what test cases failed also, but I think for this case, we would not like to show it. At least
Makes
in a
sense.
competition, you are usually not shown what test cases are passed and you're usually just expected to fix it. So I think
Yeah.
that is something we can.
Yeah, so we can discard the submission test case table, and then maybe just like score, we can have let's say I would say the test case status, test case passed as one parameter, and then test case failed as one parameter in this table only, and we can maybe maintain that directly here, right? So that we don't have to maintain a separate table for each test case. Does that
Got
make
it.
sense?
So I think one last question would be where are you storing the test cases? And then you can move to your next flow.
Yep. So I believe in most of the platform, we know that the test cases can be very large. They can be very different type of texts. Sometimes just a series of numbers. Sometimes numbers, names, strings, booleans as well. So we would like to store some kind of like a text file for each test case. And what we can have is we can have a I would say an S3 like blob storage where all of the test cases are going to be present. Each test case is going to be associated to a problem. So technically, there is going to be a dedicated problem service which is going to manage the problem cataloging, that exactly where the problem is, what the problem is, how the problem statement is, and what are the test cases of the problem. So for that, we are going to have kind of like a problem DB, right? And now inside the problem DB, we can have a problem table, which will be having all the details of the problem. And then we can have a test case table where every test case will be having a problem ID as a foreign key and this S3 link, which is going to have an input test case and expected output test case, which we can later use to match. And every time, whenever, let's say, the evaluator service starts picking up the solution, or the payload to evaluate, what it is going to do, it is going to request S3 to load all the test cases as well. So that's where the test cases are going to be.
And like, how would you actually perform this? Like, how would you actually take your test case and then actually run it against the user code, which is in any language? Basically, I want to
Yes.
understand a bit more about the evaluator.
The evaluator. Yeah, let's take a deeper dive into evaluator. That definitely makes sense. So now we have to ensure that we do like the problem because of which we didn't use the submission service servers to run our code was that we don't want to run the user's code directly on the server. This same problem can come to our evaluator feed as well. Now, one point of keeping both of these separate was to make sure that even if we get a lot of submissions, we are still able to collect all the submission and one by one process it based on our evaluators. Now, what these evaluators are going to do is they are going to actually use containers, something like a Docker container, right? And there are Amazon managed services as well that can help us to do the containerization. Anything they can do. What these containers are going to do for every language. So let's say if one of the evaluator machine collects three different, let's say reads three different payloads from this message queue. One payload is for Python, one payload is for C++, one payload is for Java. So for each separate payload incoming, it is going to create a brand new Docker container. Inside that Docker container, because in the request we are already getting the user's code, it is going to take the user's code. And along with that, inside the Docker container, we are going to also get the access to the test case that we have downloaded. If we want to improve the performance and save this round trip from S3, we can even cache these test cases maybe for a contest, but that will be very specific to the contest. And then inside the Docker container, what is going to happen is we are going to take the code and we are going to create, let's say, for example, if we consider something like C++, we are going to compile the code. If compilation failed, then we are going to immediately send a response that, okay, that this is compilation error, and we are going to update the submission DB. If compilation passed, then we are going to, let's say, take that executable binary and then one by one run it across all of our test cases. Now, for every test case that we have run, this is going to generally, a good way would be that we create our, so we have a input test case that is on S3. We have an output, expected output test case on S3. This is, these are two text files per test case per problem that we are going to receive. Now, along with this, what we are going to generate is our output test case. That while take using this input test case and when we passed it to our solution, what did we generate? So this is what we are going to generate. And then we are going to do the matching. So there are going to be two text files. And what we would
So
like to
you'll
do, we would like
generate
to
one question here. The test cases will be generated per problem or per language of the input the user is really making the submission for. What do you think?
sorry, I didn't get the question. Can you
The
please
question
repeat?
is like, how would you associate the test cases to a problem? There would be a particular defined test cases for a problem, or there would be a problem which can be coded in several languages. So every language could have, the
No, no.
test case format.
I believe test cases should be language agnostic. If I'm submitting the solution with Python, the same test cases should be evaluated with Java as well. It's just that what we can do is, so like the only difference with the languages will be the time limit, right? So what we can do is we can make sure that our Docker container do not run beyond a certain limit. If they're running, let's say, for more than 3 seconds, in order to do evaluation for per test case, then technically we should time out and send a TLE response. That is something, but I believe test cases should be language agnostic.
Got it. And with Dockers, what if a solution is exceeding the resources or the limit of resources that you have really defined?
Then,
That
like we can return the MLE. So it can return us the status code on based on which why it failed. So based on that, we can send the response back to the user that this is because for every problem in most of the platform, there is generally memory limit plus time limit. Both are defined. So let's say if the memory limit is 512 MB, so we can configure our Docker in a way that it doesn't use more than that much amount of resources. This will also allow us to run multiple Docker containers on the same machine. We cannot allow the Docker container to take all the resources of our machine. So we have to restrict the users on memory as well.
so you will spin up a new VM for each user submission, or you will
Uh,
try to reuse the containers?
Ideally, I believe a good way would be to to keep making sure that two user submissions are not, I would say, impacting each other. a new Docker container would be something that I would like to spin
So you would create a
for every
container for
submission.
each runtime that we support, like a Python different container, JavaScript
Yes.
different container, Java, and you will install those dependencies and then you will run the code. So
Yeah, so
ideally, I
like
think in that case,
Docker should not be to spin up a new Docker container. Once the Docker image is there in your machine, it will spin up the Docker container in like within a few milliseconds. So that should not be much of a effort. The problem is that why we do not want two user submissions, doesn't matter which language, to be running, in my opinion, in the same Docker container, is that, let's say, if one user's code is, let's say, a bit malicious and it's, let's say, doing a fork bomb, then the other user's code will be impacted by that. And we want independent, isolated solutions.
okay, got it. Go ahead.
So now what we are going to do, we are going to take our output test case and then we are going to do a string matching with the expected test case altogether. The moment our the string matching passed or failed is going to tell us that whether that particular test case of the problem passed or not. And similarly, we are going to do it for all the test cases, and we can evaluate our solution based on the result of this thing. If we want to also make sure that the user is able to see the result of their tests, then we would like to make sure that this output test case is also propagated to S3 so that users can later see what their code generated for each test case. If we do not want that, then we can skip persisting this to S3 altogether.
Got
Does
it.
that point make sense?
Okay.
Okay, so now once this is there, now evaluator service has the evaluation of our uh, problem. Then it will be responsibility of evaluator service to make sure that the submission status, score, how many test case passed, how many test case failed, is getting updated in the submission DB. Now, this will actually also need one thing, that in order to evaluate the problem, it needs the test cases. So evaluator service will also be communicating with the problem service in order to make sure that it gets the details of a problem altogether, right? And problem service will be talking to problem DB, right? Now, whenever the user wants to see a particular submission, what they can do is they can actually query the submission service. This submission service is going to query the submission DB, and whatever is the status update done on the submission DB, that is something that will be returned back to the user. In case
So
we
user will
want
keep
them,
polling.
yeah, so that's what is coming to that in case we want users to get kind of like a um, if we don't want to bother the user to like again and again refresh, we can make sure that we drop a support for like we provide a support for WebSockets so that in real time, whenever they want, we can actually show them the updated submission DB, I would say, status, that what is the status of the submission DB. That is something that we can support our users with. So WebSocket can be something that we can start supporting for get a submission. So to get a submission detail, we'll be having our normal API route as well, right? And what we can do is we can start supporting a WebSocket service. So now let's say there is going to be a WebSocket service. What is going to be the responsibility of the service is that let's say whenever a submission DB is getting updated, this WebSocket service is also going to update our client, right? And now, how exactly the WebSockets now? So one thing is how WebSocket service knows that something has been updated. So there are two ways. One is our DB triggers this information to WebSocket service, or what we can do is instead of asking evaluator service to directly update the submission DB, we can ask evaluator service to instead update the submission service. Submission service should be responsible for doing everything around submissions. Submission service received a response that okay, a new submission update has come up. The moment new submission update comes up, it is going to update the submission DB, and submission service can tell us the WebSocket service that, hey, WebSocket service, for this particular user, this new problem has a new update. You can actually push this to the web client. Does that point make sense?
Yeah, you can move ahead.
Got it. And then like get all submissions will again will follow a same REST API flow. one thing that we can also add up to here is that in the problem DB, for adding any problem details like the problem text, we can save kind of like a markdown string that can contain all the text, images, and the problem in case that is something that we want to ensure. Now, let's see. I believe we have the list of problems. We are able to submit, we are able to evaluate, and we are able to support multiple test cases as well. Now, talking about this particular QPS, I believe the system will be able to very easily handle these two QPS if we have enough
For
number of
users to be
evaluator
able to
machines.
see a, sorry, Sanket here, for users to be able to see a list of problems, the request should go from the API gateway to the problem statement,
Okay.
a problem service as well, I think. The first one
Oh yeah. Oh yeah.
should be.
Sorry, I missed the first one. Yeah, that's correct. So ideally to see the list of problems and even to see the problem details, that request
Yeah.
should be ideally redirected from the problem service. That makes sense. Sorry for the miss. Um, Now, what I believe is that in case we want to ensure that like any SLAs, if we feel that is missing, let's say during peak hours, during competitions, what we can ensure is that we can see that here, for example, this submission DB we have kept as a MySQL DB. What we can have is, let's say we have a caching layer in between that periodically updates our actual MySQL instance, and all the updates of a submission we are caching there so that the right time we can actually reduce. We can also make sure that the fleet of evaluator service we have enough based on how many expected users we have during the peak load altogether. Right. So there can be dedicated optimizations that we can do. If you want, we can talk about any specific thing here. But I believe
I
this
think
overall
let's
design.
talk about the leaderboard part because you will be touching upon submissions over there to be able to get it. And I think from there only we'll have a couple of, not a couple of because we don't have a lot of time, but we'll have some like optimizations that you can introduce, which you were talking about, Redis and everything. So you can give a walkthrough to me of how the leaderboard would be fetched and then how the leaderboard would be updated and move, and in that process you can try to identify a few loopholes or maybe not really loopholes but process where you can optimize the flow and then we can discuss it.
I believe for leaderboard, I believe like Redis provides us a very interesting data structure called as Redis sorted sets. Like why, first of all, I'm using Redis is because of the fact that we would like to have as fast as possible reads and writes. So a cache service like Redis is going to be good. And what we can do is we can maintain Redis sorted sets in order to ensure that for every submission, right? Whenever a submission comes up, and let's say the users, let's say competition, assuming it's a competition. So for every submission, we can calculate how many problems the user has solved for that particular contest. And based on the score, and we can write a custom algorithm that based on the score, based on the submission time, evaluates the corresponding ranks in the leaderboard. And we can have a rank object for each user for the particular contest that we can add in the Redis sorted set, right? Considering that it's a distributed cache, so that can easily scale up for us, even in case we have a lot of users available. So I believe how the flow should be is the moment evaluator service updates the submission service that, okay, a new submission has been added. What we can do is we can use submission service only to update our leaderboard based on the algorithm, right? Leaderboard update can be again asynchronous. We do not want immediately to for every evaluation because already our system is handling a lot of things. So immediately we do not want the leaderboard update to also go. So we can use this message queue again in order to make sure that like we can have a separate message queue, of course, to make sure that the leaderboard updates are patched in to our Redis sorted set, and to the users also we can actually show that the leaderboard was last updated, let's say 10 seconds ago or X seconds ago. Whenever the Redis sorted set is updated, we can update the user's leaderboard altogether. Again, we can emphasize, or I would say, we can use the WebSocket service in order to do that,
Can you show
like
how
for
you
real
would
time
store
updates.
data in the Redis sorted set, like what would be the
Okay.
format?
Okay, so in the Redis sorted side, I believe the key should be the contest ID. That for which particular, although we have not talked about the contest storage, but assuming that some contest table will be there, which will be unique, having a unique ID. So contest ID is going to be the key, and we are going to have a Redis sorted set. Right inside this Redis sorted set, what we can have is we can have a corresponding, let's say, score based on which, like, this will be kind of like the score that the user has, the user ID for the user, and the evaluated rank based on our algorithm, that what should be the corresponding rank of the users. Multiple users might be having the same rank. In that case, to avoid the, I would say, conflict, then or what I believe is that we do not need to manually calculate the rank. If we have the score of the user, and then we can have the latest submission timestamp. Let's say if our algorithm is something like whatever is whosoever has made the latest submission, based on that we are going to give the user a score. So that submission timestamp we can actually keep, and this object is going to be maintained in a sorted set. So that means anytime a new user gets the rank updated, this complete sorted set is going to get updated. This is a Redis sorted set. So this is going to be the structure that I would like to follow.
What if a person just wants to see the top 100, I would say, leaderboard top 100 people? Like, how would you
So
implement the
we can
API in that
expose,
case?
yeah, we can expose an API. We can maybe have a separate leaderboard service that can do a paginated API that can ask the user for how many number of records that they want, and then we can load this complete Redis sorted set for that API, fetch the first 100 or filter out the first 100, and then return it back to the user. I'm not very sure whether Redis gives us direct API out of the box to fetch a certain number of elements from the sorted set or not. But even if, let's say, Redis doesn't, we can manually compute that, because this is going to, let's say it's going to return us a set. We can just return the first 100 elements of the set at that point of time.
Got it. So I think we're almost out of time. You can just quickly add the Redis sorted set to the whole flow. I also want to see when exactly the Redis sorted set is getting updated, at what point of when the submission is made. And I think, yeah, that should be fine.
Yeah, sure. So as I mentioned, that we can have one more message queue that we can have where submission service is going to, let's say, whenever a user submission is going to update, submission service is also going to update this message queue as well. Um, so let's put it like this here, right? Yep. Okay. And this message queue, let's say we have a leaderboard service, because eventually we would like to fetch the leaderboard details and everything as well. So we are going to have, let's say, a leaderboard service that
I
is
think
going
once
to
the
maintain.
submission is made, we can directly update the Redis. Do we need another message queue in between? Can we not just directly update Redis?
We can do that, but there is one problem that I see there, is that in case, let's say, the submission service makes a call to the Redis service, sorry, the Redis instance, and let's say there is a network issue and that call doesn't succeed. So in that case, that submission update will never go to Redis. Here, in this way, if we make sure that our entry is there in the message queue, we can make sure that Redis sorted set is always updated. If, let's say, due to any reason it's not, we can have a dead letter queue later implemented, which can add up and later do the reconciliation.
So just for the retry purpose, you've added a message queue, not really with the fact that we can have too many requests and they would need to be processed in an order and we don't miss something. Is that
Uh,
is that understanding
Definitely, your
correct?
point is also making sense, that two requests might come after some time, and maybe there is reordering of the request. Like one request reaches the sorted set later, one reaches earlier. But because of the fact that I believe we already have the payload which has the score computed and the timestamp of the server, even if two requests reach the sorted set one after another, the eventual state of the set is going to be the same. So, but yeah, like in order to make sure that it is relatively simpler, again, message queues can be helpful there as well.
Okay, go ahead.
Yeah. And then this leaderboard service should technically pick up the data from the message queue and should be responsible for updating our Redis sorted set here. And any request for fetching the leaderboard can be redirected to leaderboard service.
So the leaderboard service will update the sorted set, is it? Shouldn't be the other way, like the where should have the updated information in Redis sorted set, and then when we want to fetch the leaderboard, we should ideally
We
be
want to
relying
give
on the
this
Redis.
responsibility to somebody. I believe submission service is a very critical service for us. We do not want to overload it or overburden it with extra responsibilities. That's the reason why I have kept a separate leaderboard service, which will be responsible for showing the users leaderboard as well, plus also responsible for updating our Redis sorted set. So anything that we have to do with the leaderboard, we can do with the Redis sorted set as well. In
But
fact, even
in
the
but eventually you're storing the submissions in the Redis sorted set, just in a optimized way for it to be fetched. So ideally, submission service should take care of updating the Redis sorted set because
sorry,
what
I
we are
didn't get your
storing in
point.
it. What
Sorry,
I'm
I didn't
saying is
catch.
that ideally, what we are storing in Redis sorted set is just an optimized way for storing the information about the submissions so that it can be fetched by the leaderboard quickly and we don't have to compute the leaderboard at runtime. Correct?
If I understand you correctly, you're saying that we are storing the data in the Redis sorted set so that we do not have to
When we compute,
recompute the leaderboard
we
again
don't
and
have to
again.
compute, correct, we don't have to really
Yeah.
compute the leaderboard.
Yes.
The leaderboard is
Yes.
readily computed for us. So
Yes.
if that's the case, then ideally the submission service should update the Redis sorted set and the leaderboard service should just look at the Redis sorted set and then go ahead and just like fetch its
Yeah,
leaderboard.
that point definitely makes sense, but I believe then in that case, don't you think submission service has one more responsibility to take care of? And let's say if there is some issue on the leaderboard updating part, then the submission service will might be impacted. Plus, submission service is already handling all of our submissions, so that will add more load to those servers. And leaderboard is not, I believe, the most critical service here, as leaderboard can be asynchronously updated. Users can see the last updated leaderboard. It doesn't need to be immediately updated. That's why I kept this responsibility to leaderboard. But if we are sure that we have enough fleet of submission service, then definitely even submission service can take care of that part.
No, that's okay. I just wanted to understand your thought process about it. But yeah, I think I do have a fair idea about the design. We do have a bigger picture on what I think the design would look like, and we've covered, I think, pretty much the functional requirements as well. And we did take a bit of a deep dive through the leaderboard flow of how would we would like to scale the system. So yeah, I think we are, I think, a bit over the time as well. So thank you, Sanket, for interviewing. This solution is something that I can take back and assess it as well. So thank you for interviewing.
Yep. Thank you. Thank you, Ria. Thank you for your time.
Thanks.